In this tutorial video, we'll start introducing you how to do object-oriented programming in Java. Eventually, we're going to go over all the ingredients for object-oriented programming. And for short, I'm just going to abbreviate object-oriented programming as OOP. Okay, so that's an acronym you want to get used to. OOP over here. And we're going to actually go over the ingredients bits by bits. For this current video, we're going to focus on how you can develop a template or in Java term classes. And the way you develop classes will be at the compile time, which means you simply by typing some characters or by keystrokes on the Eclipse editor. And then we're going to see how you can define attributes, and eventually we're going to see how you can define three kinds of methods. Each method is basically just a block of code they can actually keep calling to reuse. And specifically, we're going to see how you can define constructor, which is a very special kind of method. And then we're also going to see how you can create instances or entities. In Java terms, how you can create objects. And objects are runtime phenomenon, which means you have to execute a code in order to visualize the objects. Okay, so these are the parts we're going to focus on for the current video, and we're going to go back to the remaining parts for later videos. As an example, let me just give you a little bit background over here. Okay, so every time when you want to do object-oriented programming, you want to be given a problem to solve. So let's say this is a problem we want to solve, which is written in natural language, English. So let's read it over very quickly. So points on a two-dimensional plane are identified by their sign distances from the x and y axes. So which means we got basically two values to actually characterize what a point is in a two-dimensional plane, the x and the y coordinates. A point may move arbitrarily towards any direction on the plane, which means it might move up, down, left, or right, or even diagonally. Given 2 points, we are often interested in knowing the distance between them. Let's say I'm given a point in P1, and then I want to know what's the distance between P1 and P2. So we are trying to solve some simple problems on a two-dimensional plane, which you did, I believe, previously in your high school math. Okay, but we're going to try with something you're familiar with. Okay, so now I want to mention something very quickly to give you some tips. So typically when you're given a problem to solve and the problem is actually specified in natural language, and English is just one example, and like the one we just went over, what you typically want to do is to identify the critical. So here I mentioned the word critical, which means you want to be selective. You don't have to identify every noun and verb and translate them into some corresponding stuff in Java. You only selectively choose some nouns and verbs and translate it into classes, attributes, and methods. So the rough rules over here, let me just write it down. For the critical nouns, you're going to turn them into either classes or attributes. On the other hand, for the critical verbs, like actions that you would like to perform on entities, they will be turned into methods. Okay, let's just see example very quickly. So in the case of the two-dimensional points, so I would say the points over here are a class of entities. So we will turn that into a Java class. On the other hand, what about the attributes? Attributes over here, let me just mention very quickly. Attributes are basically characteristics of each of the entities of a particular kind. So in this case, you can see their sign distances from the x and y axes, which means for each point on the two-dimensional points, how do we characterize it? So now let me draw a picture quickly. So let's say this is the normal two-dimensional plane. You got x-axis, you got y-axis. Let's say I have a particular point over here. So this is the distance from the y-axis. So that'll be the x-coordinate value. And also this is the distance from the x-axis. So this will be the y-coordinates. For each point, we're simply going to characterize it by using the x and y coordinate value. So the two values. Okay. So these are the distances. So that will be attributes. Okay, so now if I go back to the ingredient summary over here, whenever you talk about attributes, they're basically characteristic of each kind of the entity that you're talking about. Okay, so they are kind of static. You just describe what the entity is like for that particular category. Okay, so let's go back here. And then we also say that, so that'll be the, so now we have covered classes, we got attributes. What about methods? You can think about methods is just a way for you to actually either to query or ask a question about some objects, or to really change the values of the objects. That's something we'll go into details, but I'm just trying to give you some intuition over here. In this particular problem text, so let me use a different color here. So now, for example, you can see that over here, you can see a point may move arbitrarily towards any direction, in this case being up, down, left, and right. So that's kind of like a verb. And also, given 2 points, we are often interested in knowing the distance between them, which means we want to obtain the distance between 2 points. Okay, so the orange will be turned into a class, which is called point, and we'll do that in this current video. And also the pink will be turned into 2 attributes, like x and y. For example, over here, we can have, rather than x and y, it could be maybe 2.0 and 4.6, right? That's a particular, there's a one particular point at the plane. Of course, at the runtime, we can instantiate as many points as we like. It can be a point in the over here, it can be a point over here, it can also be a point over here, as many points as we think necessary. Okay, and the green one over here is going to be turned into methods, which we will do in later videos. Okay, that's kind of the thinking process or analysis process you want to have for each problem you're given to solve. Okay, later on we're going to solve different problems towards the end of the course to really get you familiar with the process for object-oriented programming. Okay, so now what we will do is we're going to see how we can try to do a point class, and also how we can define the attributes over here. Basically, attributes are like variables that can be visible to every method you define in a particular class. Let's see exactly how that's going to happen, because we also have to explain to you the scope for the variables as well. Okay, so let's go to Eclipse over here and do some programming, and then we'll go back and forth between the slides, the iPad, and Eclipse. So now I assume that you're going to create a Java project for this week, lab number 5. Okay, create a project first before you continue. So I'm gonna create a new class under the source folder. Let's call it points. Okay, so when you create a class, a naming convention to remind you about. Okay, it's going to be capitalized, and for each compound word, it has to be capitalized as well. Okay, in this case, I'll simply say points rather than points. Okay. Typically, the noun for the class should be singular for the reason that we are going to create as many points as we like from this particular template for the point. Okay, one more thing to mention. Over here, whenever you talk about Java class, for example, the point class we're going to create, we're going to define basically the common attributes for every point instance. Okay, and then we can create as many instances for the point as we like at the runtime. Okay, that's why the point class itself should be singular, and we can create as many objects at runtime as we like. Okay, so now it would be point, and now notice that unlike the previous lab exercises, we are not going to create a main method anymore. Basically, we would like to have the following mental picture. Let me just go back to iPad very quickly again. Previously, in your lab exercise, you're always creating some console application, for example, tester, or it can be Fibonacci sequence app. And you always have a main method over here. It's still going to be true from now on for the object-oriented programming. However, you want to have the following mental picture. You're still going to have a tester or maybe some application class that is going to have the main method. Okay. However, there's only a single class with this particular main method. That's it. However, we're going to have another mental boundary over here called model. Model in the sense that every class that we're going to create under this boundary for model is going to correspond to some real problem that we're trying to solve. For example, let's say in the case of the point class, the point problem, we're going to have the point class in the model boundary. But in theory, you can have as many classes as you like over here. So in this course, we're going to show you how you can maybe define under the model boundary, maybe for about 3 or 4 classes working together. Okay. However, you still have just one single main method, just a single, only a single main method. On the other hand, for all the classes you define under the model boundary, you have no main method. Okay. All the classes over here, there will be no main methods. So later on, when you actually want to test or try to run your application, you always have to go to the tester, the single tester over here, run it as Java application, and it's going to execute a main method line by line. And what will we do? Basically, each line of the code in the main method in the tester or application class is going to somehow create a new object of a particular client. Can be create an object from here, create an object from here, and try to call methods on the objects eventually. That's something we'll see. Okay, again, single tester and then multiple classes without the main methods inside this model boundary. Okay, that's something I want you to get clear right in the beginning. Okay, but for our particular case, we have only one class under the model boundary. Okay, which is point. And then I'm gonna create a tester in a little bit later. Possibly in this video or the next video. We'll do a little bit later. We'll see how the time goes. Okay, so now we're going to have the point class, and now it's under the model boundary, so we have no main method. So we don't click on this box over here. And then we'll say finish. Okay, so now we have the point class over here. Let me maximize it. And now you do not have to worry about the public modifier that's automatically generated for you. We are not going to worry about this public for this course. Okay, just keep it over there. Public simply means every other class in the same project can actually use it. Okay, that's simply what it means. Okay, but you can just leave it over there. So now, this is how I would suggest that you organize your point class or every other class you're going to define for this course in the following way. We want to define the first section being all the attributes. Attributes are class level variables that you can define first. And then we're going to define the various kinds of methods, namely constructors, accessors, and mutators. So those are the methods we want to define after we define the attributes. Okay, let me just show you here. So let me give you a little bit of comments over here. For the case of the points, so let me just write some comment here. Okay, so now this class is a template for two-dimensional points. Okay. At runtime, we may instantiate as many 2D point instances as we wish. Okay, just give you some idea over here. Basically, the same idea is going to apply to every class you're gonna create later. So now, inside the class, you can see this is basically the contents of the class, right? You can see starting with a curly brackets, ending with another curly brackets. So now let's define the first section, which will be attributes, the characteristic. Think about for each point you have, what kind of characteristic should it have for every point? Well, in this case, we decide it's going to be the x and y coordinates. So we're going to define attributes. So the first section will be our attributes. They're basically class level variables. And as soon as I talk about variables, you can recall what we talked about back in the elementary programming tutorial videos. Whenever you want to declare a variable, you have to give its type and its name. Okay, the same idea as before. It's just now we call them attributes. Whenever we don't really say usually class level variables. Okay, for object-oriented programming, we normally refer them to as attributes. Okay, and now what's more important is over here. So the scope of attributes are every method in the class, in the current class. When I say current class, the class that we're considering right now, the class where the attributes are residing in. So in this case, the point class. Okay. So now let me write it, and then everything will make sense after I give you more illustration. So now the first, I'm going to define two attributes. So first one, I'm going to be, let's say, give a type for the x and y coordinates. I can say double and x. So typically, you do not give any initial value. Okay. Okay, I'll say typically you do not initialize the attributes here. Okay, so you wouldn't say double x is assigned to 0.0 or 0.7. You don't do it here. It's not wrong, but it's just not the way to do object-oriented programming. You only try to initialize the attributes in the constructor, as I will show you. Okay, that's a more appropriate to do so. Okay, I would suggest you follow you follow the good style when you first learn about object-oriented programming. Okay, if you used to do initialization right in this line, try to get rid of that bad habits. Okay, so now in the next one, I'll say double and then y. Okay, so now we only declare the types of two attributes without initializing them. We will do the initialization for these two attributes in the various constructors. When I say various, I mean we can define more than one constructors. So I want to show you. Okay, so now we only got two attributes over here. That simply means every point as a template, basically between every points that can ever be created, all of them, each one of them possesses two attributes. One is the x coordinates and the other one is y coordinates. Okay, that's about the attributes. And now once we have done the attribute part, we're going to see how we can construct a new instance from this particular template, right? You can see the class is a template. So now the template is only compile time. You can see so far we are only trying to edit the code inside the Eclipse, making sure everything compiles. As soon as it compiles, we can now try to instantiate the template to create different instances, in which case we need a tester. Okay, before we do that, let's create a mechanism for us to construct new instances, in which case we need constructors. Okay, so if I go back over here to the iPad over here, so this is y. Once we finish defining the two attributes in the point class, we want to define methods. And for this particular tutorial video, we're going to focus on the first kind of special methods called constructor. Okay, constructor basically just for us to create new instances. So something I would like you to really pay attention to when we talk about templates is simply define what's going to be common between all the instances. And as soon as you say create new instances, we're basically instantiating a particular template by assigning some instance specific values. Okay, over there. We're going to see exactly what I mean over here. Okay, so now let's define the constructor. Okay, so now I'm going to show you two versions of the constructor. Okay, so now for simplicity in this particular video, I'm going to make all the variables with unique names, with no possibility of name clashes. But in the next video, we're going to show you an easier way to do things. But for now, let's just start with something that's more simple. Okay, we don't want to have too much complication in the beginning. So now, I would like to define the constructor over here. So now the second section I'm going to have is going to be constructor. Constructor will be methods for. Okay, you know what? I would like to say methods over here in the sense that it's not a very typical kind of methods. It's a method only used for a particular scenario, which is for creating instances. Okay, say methods for constructing new instances of, not person, sorry, point. Okay, so now how can we do it? Okay, so let me just write out the syntax first, and then I'll talk about how you can interpret that. Okay, so for now we are trying to define constructors. Okay, okay, so now I want you to note. Okay, note here we are defining definition. There's a reason why I'm trying to emphasize definition over here. We are defining constructors. Because in other contexts, we're going to use constructors, which will have different syntax. And you want to make sure you understand both and also distinguish between which one is which. So now we're defining constructors. So now here is number one rule. Okay, let me just give you the rule. The rule is the name of constructor must be the same as the class name. It must be the same. If you want to create a constructors for a point, it must be called point. Okay. In this case, we're just going to give the name of the constructor over here, just point. The easiest one you can simply define is something like this, just point. Okay, and then you have to start with a left parenthesis and also ending with a right parenthesis like this. Okay, and then you may supply as many inputs as you like. Let me write one version. Let me write two versions for you, and then I will explain. Okay, so over here I got point here, and then I'm just going to say double. Let's say new x. Okay, so the reason I choose new x rather than x is because the new x is different from the name for x, so we don't have any name clashes. Okay, and then we're gonna say double new y. Okay, that's what I would do over here. Which means I'm simply just going to, actually, whenever I want to construct a new instance for the points, I'm going to give you two values, the x value and also the y value. For example, if you look at the points I just talked about before, if I want to create an instance that corresponds to this particular points, I'm going to give new x being 2.0 and new y being 4.6. If I want to create another points, I can do the same. Okay, something similar. Okay. So now this is the first constructor I have. And then what about what I can do inside this particular constructor? I'll do that in just one moment. Okay, I'll be there. Okay, I want to show you two versions of the constructor. So here's the rule. You can define as many constructors as you wish. You can, but typically you should need at least one constructor, at least one. But now in this tutorial, I want to show you two constructors, so you're gonna get a feel. So two constructors simply means you have two different ways to create instances. Okay, let me write down exactly what this constructor look like, and then I'm going to illustrate to you. Okay, so now I have another constructor which has the same name. So now you might be wondering, wouldn't Eclipse be confused because the two constructors have the same name? The answer is, as long as the list of inputs you have either have different size or they have different types. As long as you actually keep the two lists of input variables to be different, then the Eclipse will not be confused. Okay, let me show you what I mean. So I can say over here, I want to do, let's say character, and then I would say axis. I'll explain what this constructor is supposed to do in just a moment. Okay, axis, and also let's say double distance. Okay, so basically now I would say, I will give you some comments over here. Okay, version number 1. Okay, that's a version number 1 constructor. Okay, creates a new points using two values for x and y coordinates. Okay, and also version 2. Create a new point either along the x axis or along the y axis. So what do I mean by that? Let me just give you one example over here. So now let's say this. If I want to create a point that is going to be along the x-axis over here, for example, I want to create this particular point. Okay, of course, one way to do it, I can simply say I want to create this particular point. It's going to, I'm going to give 4, let's say, I'm going to give maybe -4 and then 0. So I'm going to give -4 as the x value and 0 as the y value. That's one way to do it. But remember, every point along the x-axis always have the second value being 0. So maybe I can have a more convenient way not to mention that anymore, right? So maybe I can simply say, now I want to create a point along the x-axis, but now the distance between the points between the point and the origin is simply -4. Okay, that's something I want to create. Similarly, what if I want to create a point over here? Let's say this is the point I want to create along the y-axis. Let's say this point here is simply, let's say 6 and then 0 and then 6. 0 and then 6. In this case, you can see every point along the y-axis is always going to have their x value being 0. So maybe I can simply have an easier way by not mentioning it. So I can say, now I want to create a point along the y-axis, and then I simply want to have the distance between the points and the origin being 6. Okay? So now, how do we specify whether that should be x-axis or y-axis? Let's say we simply use a character as the input. You can either say, if that happens to be x, that means the x-axis. Okay? If that's actually y, it's going to be the y-axis. Okay, so we just have this kind of way to actually specify. You can see, so the two constructors are just different ways of creating objects. The second way over here is more specialized because I want to have a particular point that's either along the x-axis or the y-axis. And the first version over here is much more general because any points can just be identified using the x and y value. Okay, you can think about we can somehow you can think about this is more general and this is more specialized. I'll show you also something that's also very cool idea. Okay, so now we have these two versions of the constructor for the class, right? So now I want to say one thing more about a scope for the variables before I go on and then give you a definition. Okay, let me just make a snapshot of what we have done so far. Okay, the complete picture for the class over here. I want to give you a very clear mental picture about the scope for the variables, for the attributes. Okay, let me just paste the code fragment for the points. Currently, the body for the constructors are simply just empty. That's intentional because I want to show you exactly how you can visualize the scope. Okay, that's hopefully that's big enough. Okay, I want to really draw your attention to this. Okay, you can see that over here. So these are the variables at the class level. You can see directly under the class called points, we have these two variables. So these are the class level, which means the scope is within every methods inside this particular class, which is point. What does that mean? That means you can refer to either X or Y or both inside every method that we're going to define, including constructors for this current video. Which means inside the body of this particular methods over here, you may refer to X, you may also refer to Y, whichever you think necessary. Similarly, inside this particular method over here, you may refer to X, you may also refer to Y. Okay, I hope that's clear to you, right? That's about the scope for the variables. Any attributes you declare for this particular class, we can add more attributes as you wish for other classes, right? As soon as you declare the attributes over here, once you start defining the methods, you can always refer to any of the attributes inside, okay? So whenever you do any reassignments, let's say whenever you do any reassignment for the X inside a particular method, that simply means you want to modify the value for the attributes for some particular objects. We'll see exactly what I mean over here. Okay. So now that is about the scope for the attributes. I want to say one more thing over here. You can see this is the name for the constructor. You can see both of them are simply called points, right? That's the name for the constructor over here. And then I want to talk about the what's inside this particular round parenthesis over here. You can see the round parenthesis over here and the round parenthesis over here. Okay, what's inside over here? Let me say exactly over here. Okay, let me just say this. It's going to be comma separated variable declaration basically. So this is so-called parameter list. Input parameter list. Okay, so this is one particular input parameter, this is just another one, and this is just another one. Okay, you can have as many input parameter as you like in the list. The simplest one would be the input is simply the list is simply just empty. So you may have, for example, points over here, and then you simply have empty list of parameters. That's also possible. Okay, but in this case, we have. Let me just use a different color to really represent. Oh, orange is fine. So for this version 1 of the constructor, we have parameter number 1, comma, parameter number 2. So we have 2 parameters. What about version number 2? We have parameter number 1 over here, followed by comma, and then parameter number 2. You can see the size of the 2 lists of the parameters are simply the same. Okay, they're simply the same. But how can Eclipse not be confused about which version to actually use? It's simply because you can see for the very first parameter in both lists, their types are just not the same, which means when I'm calling using a double value for the first input, I would know that I'm calling the first version. If I'm trying to use a character as the first input, I would know that I'm calling the second version. Okay, now so let me calling is just by use. I simply mean by using. We'll get there. Okay, again, you can see that these two places, I'm simply just defining the constructor. So now I haven't talked about how to use the constructor yet. Okay, well, we'll get there. So now one more thing to say. So now what about the scope for the input variables? Input parameter simply means Okay, input parameter list. They simply suggest the input values to pass when you call or use the method, or in this case, constructor. Okay, it's really important. So if I have two inputs over here, if I want to use this particular version 1 constructor, I have to give you exactly two values. This first value must be a double, and the second value must be a double as well. And each one of them is going to be new x and new y respectively. So the order is important. Okay, and if I want to use the second version of the constructor, I also need to pass two input values. However, it will be a little bit different. The first input value for version number 2 will be a character, and the second value for the version 2 constructor will be a double, right? Okay, and the first character will just be meaning axis, either x or y, and also distance will be the distance from the origin, right? So now, what about the scope for the input variables? The scope for the input variables is only within that particular method, which means inside the version 1 constructor, I can refer to new x, I can also refer to new y. That's no problem. Okay, you can refer to both of them. Okay, and however, you cannot refer to other you cannot refer to the input parameters from other methods. For example, if you try to refer to axis, or if you try to refer to distance, this is not allowed. Okay, let me just emphasize that. So this is not allowed because axis belongs to this method, and also distance is not allowed because it belongs to this method particularly. Okay, and what's more, similarly, you can see for this version 2 constructor, I can definitely refer to axis. I can also refer to distance, right? Because they belong to the same method for this particular method we're talking about. On the other hand, over here, I cannot refer to new x because new x comes from another method. I also cannot refer to new y because it comes from another method. Okay, let me emphasize that. You cannot refer to new x. You also cannot refer to new y. Okay, that's a very important first step for you to understand even before we try to define the constructor body. Okay, you want to make sure you understand the scope for the attributes which is within every method, including constructor, that you can define in your class, and also what's the scope for the input parameters that you define for the constructor or the method, which will be within that particular method only. You cannot use the parameter for another method. That's simply not allowed. Okay, as we try to say here. Okay, once you understand the idea about the scope for attributes and also method parameters, now we can go back and try to define something, and then I will show you how you can visualize the effects for calling the constructor. Okay. So now for this particular one, let me write down the code for you, okay, and then I'll explain. Basically, you want to say, if I call the first version of the constructor, that means I want to create a new points with the x coordinates being new x and the y coordinates being new y. Okay, so what I should do is, you can think about this. These two attributes are the attribute values for a particular point object or point instance. So now I want to really initialize the x value. And remember I said before, typically you do not initialize the attribute value when you declare them. You want to only reassign or initialize the you only want to initialize the attribute value in the constructor. So in this case, I can say the attribute value x over here is going to be assigned to new x. Remember, new x is within the scope of this particular method. Now notice one thing. If you move your mouse over new x, you can see it tells you new x is referring to whatever value you pass as a new x over here. And if you move your mouse over x over here, it's referring to, you can see the use of x in line number 22 tells you that it's using the x that's declared in line number 11. Okay, that's some useful highlights that Eclipse is showing you. Okay, I'm simply saying whatever new x you give to me, I'm going to use that value and reassign or initialize the x value. Okay, we're going to visualize this. And then similarly, I will say y is reassigned to new y. A very typical mistake is when you say rather, you would say new x is reassigned to x. So this is simply not, you can see there's no compile time error, but this is not right. What you're saying in line number 24, which is completely wrong. you are saying that I'm going to get whatever value I want to initialize x into, I'm going to reassign that into the current value for x. Well, it simply doesn't make sense. Okay, let me simply, this is not right. Not right. You should never reassign input parameter. Okay, that's something you want to avoid always. Okay, after this, so that will be the definition for this particular constructor. Okay, I'm gonna explain to you exactly, gonna visualize both constructors in just a moment. But now I'm gonna define the second one. The second one is gonna be interesting. So now I want you to not abandon what you learned previously before we talk about OOP. So previously, before OOP, we talk about elementary programming, we talk about selections, we talk about loops. All of those might be useful when you actually try to define methods in your class right now. Okay. In this particular case, we want to say if the access input value over here happens to be x. Let's assume the access value over here can either be character x if we want to create a point along the x-axis, or it can be character y if we want to create a point along the y-axis. Okay, it can be either x or y. Depending on which one is which, we're going to create a point accordingly, right? So let's see exactly how we can do it. So now we have a selective action, so we can use selection inside the constructor. Okay, so we can say if access over here, remember, is character, so we have to use equal to compare its value. We only use equals to compare string. That's the only occasion. Okay, so now we can say access if it is simply just x. Okay, what does that mean? That means we want to create a point along, as I drew before. If you want to create a point along the x-axis, that simply means the y value is going to be 0, and then whatever the distance you make, you're going to make the whatever distance you give is going to be the x value. Okay, so just make sure you understand that. Okay, so now along the x-axis, so we will simply say if axis is simply x, so the x value is just going to be the distance, and the y value is just going to be 0, like that. Okay, in some way, thinking this way intuitively, I'm going to show you programmatically. If the axis happens to be x, it would be as if we try to call the first version of the constructor with the new x being distance and the new y being 0. Okay, I will see exactly how you can apply that intuition a little bit later. Okay, for now, let's just understand the logic. And of course, let me just write one more line for you. So we have the assumption over here. Axis can either be x or y. Okay, it can be x if a point is created along the x-axis, or y, and similarly, right? If a point is created along the y-axis, right? I don't need to type it. Okay, so now we assume that. So now it's either going to be x, otherwise it's going to be y. So we can say else, if else, since we have that assumption. So now I'm going to say x is, so now if I want to create along the y-axis, for example, this particular point over here, every point along the y-axis is going to have their x value being 0 over here, right? And the y value can be whatever distance you pass between the origin. So what I will do is I'm going to say x is going to be 0 over here. You can see it's symmetric, right? And then y is assigned to the distance. Okay, so it really depends on what character you pass when you call the constructor, but we're going to see the call in just a moment. Okay, you can see that over here we have, basically we define the two attributes for your point class, and also we have the two versions of constructor for constructing the points for different scenarios. Okay, so this one here is much more general. You just give x and y value, and this version is more specialized. You want to create either way, either the x coordinates must be 0 because we want to create along the y-axis, or the y coordinate value can be 0 if we want to create along the x-axis. Okay, either way. So now let's see exactly how we can use it use a constructor. Let me write out. I will definitely go back to here and try to explain to you how exactly is the block of code for the method is going to be executed. Before I do that, let me just give you a little bit more code, and then we'll trace all together to make sure you understand. So now remember this picture we just drew over here. So we want to make sure that we have. So far we have only one class over here, which is the points. That's what we just defined over here, the point. So now we want to make sure we can actually test it. We want to create some simple application. So either you want to test or you want to create a console application. Then you will actually need to create a class with the main method. That's exactly what we're going to do right now. Okay. And for the lab exercises, you also have to create a console application yourself with the main method. Okay. So now I'm just going to create a tester. Okay. So now what I will do is I will go back to this particular package over here, right click, and then say new, and then class. Okay, and then I would say, you can say tester, or maybe I can make it more informative. I can say point tester. You can see it's a compound word, so every word should be capitalized. And now in this case, I'm going to have the main method, which means in this particular class, I'm actually going to create and manipulate point objects over here. Okay, I'm going to do that. I'll say finish over here. Okay, so now for the main method over here, let's say number one we're going to do is we're going to create point objects. Okay, so now basically we can do the following. Let me write out the syntax first. First of all, you want to declare the variables of type points. You would say points, let's say P1 is assigned to new point, and then I will explain the syntax, don't worry. And then and over here, let's call the first version. You can say, what about 3 and 4? Let me give you something negative. How about that? Let's say 3 and minus 4. Okay, and then also we got point P2. And then we're going to have new point, let's say minus 2, and then minus 6. Okay, and then we're going to have, actually I think that'll be enough. Let me make it more interesting for you. Okay, the first line is, okay, I'll say calling the first version constructor. Okay, let me make sure I call the second version. If I want to call the second version, let's say I want to create a point along the x-axis. Let's say I put x over here, and then how about y? And then I'm gonna put, let's say 8 over here. Okay, so now you can see both lines compile, calling the second version of constructor. Okay, so we got two lines over here. Basically what I'm doing here, briefly speaking, I'm gonna trace the code in just a moment. Basically what we have is we got P1 and we got P2. They are simply just variables. Okay, and the type for the variable is using the class name of the class that we just defined, which is the point. Okay, this is something new to you. Previously, you only declare variables like an int, boolean, character, or double integer, stuff like that. But now, every time when you define a class on your own, you can definitely use the name of the class you just defined as the type for the variables. And the meaning is very important to understand. I'll get there. And then whenever you want to create new objects, you have to use the keyword new. Okay, and then you want to call the constructor. And you can see in this case, because we passed two numbers over here, so now we are calling the first version of the constructor, which is expecting two doubles. On the other hand, you can see the second call over here, we are calling by a character followed by a number. In that case, we are calling the second constructor over here. So there's no ambiguity. Okay. So now I'm gonna visualize exactly what's going on over here and trace the code. Okay. So basically we got two classes over here. We have to understand all together. We have, let me say one more thing. This is where we call or use the constructor. Okay, let me just make it capitalized. If you remember in the previous developments over here, I say something like here we are defining constructors, right? So this is the place where we define the constructors. And this is the place where we call the constructors. One is about definition, the other one is about usage, right? You want to be very clear about the difference between the two. Okay, so now we're gonna trace the code all together. Okay, so now I'm gonna copy the code. Okay, so now number one, I'm just going to, you know what? Temporarily, I'm just going to delete the comments so I can make more space for myself. Okay, I'm gonna undo the comments. Okay, temporarily, I'm just going to see if I can make a whole snapshot for the class. That's okay. I think that will do. Okay, version 1, version 2. So I'm going to make a snapshot for the program over here with, okay, I think that'll be enough. Okay, I don't need to worry about the comments because you got the comments already. Okay, so now I'm going to have a new page over here, and then I'm going to paste it. Okay, so bear with me. It's going to be done in just one moment. Okay, so this is the point class over here with the two attributes and the two constructors. Okay, and then I'm just going to go back over here. Let me undo the comments so I don't lose them. Okay, so now let me go to where we use the constructor, the tester. Okay, and then I'm just going to have this. Okay, I'm just going to copy this particular code in here. Okay, again, the comments I don't need to capture them completely. Oh, let me do it again. Sorry, did it wrong. Okay, I'm gonna capture this part only, and then let me go back to iPad. Okay, and then I'm going to paste that fragment again. Okay, that's a tester. Okay, so now hopefully it's clear to you. We have two separate classes over here. Okay, you can see over here we have two attributes and also version 1 of the constructor, version 2 of the constructor, and also we have two calling the version 1, calling version 2, right? So these are the these are several things we want to get clear about. Okay, so now what I would like to do is let's try to trace the code. Okay, let's see this. So when you try to run the point tester as Java application, you can only do that, but not here. If you try to right click on the points and try to run it as Java application, it wouldn't be an option because there's no main method. Okay, so now if you try to run this main method here, I'm going to execute line by line, this line first and then this line second. Okay, so now I want to explain what this line really means. Okay, so now I want to focus on line number 1 and give you sufficient details. Okay, so now this is how you can think of it. Okay, what's going to happen is for this particular line here, so there are 3 parts basically. So let me use color to actually show you. Okay, part number 1 is this part over here where we have the new expression here. New expression simply means, so we have new keyword followed by a call to the constructor and then given some input variable, given some input values over there, 3 and -4 in this case. And then the second part is basically we declare the variable over here called P1 of type points. Okay, and part number 3 is basically, I'll put in blue, part number 3 is we somehow try to link the 2 parts together using an assignment. But how do we link everything together? That's something I want to explain to you. Let's focus on the orange part first. The orange part here is how you can, this is how you can think of it. Whenever you're trying to use the new keyword over here, that means you want to create a new objects. But what kind of objects are you going to create at the runtime? Okay, by the way, this is already the runtime, right? So you want to, whenever you talk about new over here, it's really about runtime construction. And when you try to create a new objects, it's really about allocating some memory, some space for you to store the objects. Okay, so let me go a little bit lower level details for you to really get it clarified. Okay, I'll just give you a little bit low. Okay, and then once we understand it for the very first time, we can go back to more higher level stuff. Okay, so now think about this is your computer memory over here. Okay, as we said previously, the computer memory is simply a sequence of bytes. Okay, So now you can see basically this one region of the memory. Okay, let's say here. Okay, each one of them is a single bytes, for example. Things like that. Okay, and then each one of them, each byte also has a memory address. For example, for this particular one, it could be 061121. I'll just make it up. Okay, absolute value for the address is not important. Okay, and then so now whenever we try to say the new keyword over here, that means we are allocating somewhere in the memory, and we are trying to create a particular object over here by calling the constructor. You can see that's why having the same name as a class is really important. As soon as we see that this is a constructor name followed by the new keyword, we know that we should go to this particular class over here. Okay, once we go to that particular class, but there are more than one versions of the constructor at the moment. So what should we do? You should really, the compiler, the Eclipse, you will actually look at the first one to expect is simply just a number. In this case, between the two versions of the constructor, which one is expecting a number as a first input? Well, it seems like only this one over here, right? Because for the second version, it is expecting character as a first input. So calling this must be the first version, okay? Must be the first version. Okay, so we must be calling the first version of the constructor over here. Okay, let's just make sure it's understood. Okay, so now as soon as we know that we are calling the constructor from the point class, so that means we're allocating a memory for the objects of type points. Okay, so now how is the memory allocated? Basically, it goes like this. So let me just put the points over here, the class name. So this means we are creating objects of type points. So now what information should be stored for each point? Basically, you have to look at the attributes. Remember, we say that each class is simply just a template. A template defines for every point objects what characteristics should they bear. In this case, each one of them is going to contain x being a double and also y being a double. Okay, so that means we're going to have x value over here, and also we have the y value over here. Okay, so these are the two pieces of information for every point over here. Of course, each one of them is going to occupy some space of the memory. Okay, so this may not be exactly accurate at the hardware level, but conceptually that would be sufficient. So that means for this particular region of the memory, we are storing information about this particular new objects we are creating over here, right? Over here. So now, but how exactly do we actually store the value for 3 and also the value for -4? So that's the issue you want to deal with, okay? So now, you can think about so let's think about what is a method, okay? A method, let me write it down. A method is simply a reusable block of code. A block of code, which means every time if you want to, whenever you call a particular method, in this case constructor, it's just going to execute the same block of code, because just by mentioning the name of the method or the constructor, you can actually execute the same block of code. So reusable over here is really important. So you don't have to define many versions. You don't have to really simply write the same block of code over and over every time you try to call the method, right? You can just use its name. Like in this case, we'll simply use the name for the constructor, which is called points, and then give 3 and -4. So now, how do you understand the calling for this particular constructor over here? You can see over here, the first, let me go back to consistent color here. The first input value we're using is 3, which means new x over here should be, we are expecting, for the new x, we are expecting double. Oh, let me say one more thing. Because we mentioned that this is where you try to define this particular version of the constructor. And this is where you try to use this particular version of the constructor. When you try to define the constructor, you work at the level of the input variables, because the way you say that the x and y attribute should be assigned is based on whatever value you get for new x and new y. So here you just talk about in terms of the input variable names, the parameter variable names. But now, as soon as we have a particular call to actually execute 3 and minus 4. That means we're going to, for the case of 3, it's going to replace every occurrence of new x over here. So new x is just going to be 3 over here. Okay, it's as if we try to replace every occurrence of new x by 3 for this particular call. Okay, and then similarly, also you can see for the new y, it's just going to be minus 4. So for every occurrence of new y, it's also going to be replaced by minus 4. So what would that boil down to be? It's just going to be x is assigned to 3, and also y is assigned to minus 4. Okay, what is x and what is y? So the x and y are basically the attribute value for the current objects that we are trying to create, right? So x will be assigned to 3 and y will be assigned to minus 4. Okay, that's exactly how we actually try to execute this block of code over here. So what if we have just another point to be created, right? Let's think about it very quickly. Okay, so now what if I just try to do, let me just finish this discussion here, and then I'll give you another example. Okay, so now this is part 1. The orange part that we just talked about over here is about how you execute new point 3 minus 4. Okay, that's a right hand side part. And what about the pink one over here? Basically, whenever you say points P1, you are declaring a variable named P1, and the type is simply just point. Okay, but what does that really mean? So P1, you can think about P1 is simply just a variable over here. So P1. Okay, and then P1 is going to store some value, but what is the value P1 is going to store? Because when we talk about objects creation, what we just created from the orange part is going to occupy somewhere in the memory, starting from the address 061121. Of course, the absolute value for the address doesn't really matter. So now in this case, P1 is going to store, let me write it down here. P1 is going to store the address or starting address, the address of some point objects. So this is exactly what's going to happen over here. So that means P1 is actually going to store some address. Okay, it's going to store address of some point objects. Okay, let me just repeat it quickly. So now, that's a pink part. We simply declare the variable, and we know that you can only store the address of some point objects into it. That's the only thing you can store into it. Okay. So now, what about the assignments over here? The assignments over here, it simply means we're going to store whatever the new objects we just created, its starting address into P1, because P1 is expecting to store some point address. Okay. So now in this case, the address for this particular point we just created is 061121. So we're going to store it 061121. So notice one thing, P1 is really important for you to notice. P1 does not store the x and y value together. It does not, because we got two variables to be stored, and in general, an object can contain as many variables as you like. It can be very huge. So now P1 over here, a more general solution is to say P1, rather than storing all the variables, all the class, all the attributes for the objects over here, is going to store just the starting address of the object in the memory. Okay, so now that's why in this case 061121 is exactly stored over here. So the advantage of this is when we look at P1, we have to somehow to say, given this particular address in the memory, we're going to look up that particular position in the memory, and from there we can look up what's the x and what's the y. So in some ways indirect. Okay, so now this is indirect rather than direct. So if you only look at P1 itself, you don't actually know what is the x value for the objects and what is the y value for the object. You have to somehow have a lookup operation, and we have an operator for that. We'll talk about that a little bit later. Okay, so now what we can, so basically P1 is going to store the address over here, but now, okay, that's about the memory case. Okay, so now, so this will be the only time I'm going to explain to you how exactly things work at the memory level. So now, how do we draw things in a more convenient way? Okay, we want to make sure we address there's an object over there, and also the way P1 store the objects indirect. It doesn't store the object contents, it only store the object address. Okay, so that's how I would draw it in this way. Okay, so now in summary, this is how you should draw after executing the first line. First of all, we're going to use a rectangle box to represent the object that's being created, and then you should really give a title for the box. In this case, it's going to be point. And given that it's a point object, so we should have contain all the attribute values to characterize that particular object, x and y. Remember, the way we characterize each object is by the attributes for its particular class, right? So now in this case, it's going to be two attributes, x and y, and we draw the attribute names at the left-hand side column. Okay, and then what about the object-specific value for the attributes? In this case, it's going to be 3 and 4. So it's going to be 3 and also minus 4. So we got 3 and also minus 4 over here. Okay, 3 minus 4. And then how do we, as soon as we declare some variable over here, P1 for example. Okay, so P1 is basically a point type variable. So now, so the way we say P1 doesn't store the entire object per se, it does not. It only indirectly store the address for the objects in the memory. So we can simply use this notation. We simply say P1 points to this particular object over here. It points to there. So once it points to there, we know that by looking at P1 directly, we don't know what x is and what y is. We have to somehow follow this particular arrow to actually get to that particular object before we can see what the x is and what the y is. So now this is how you draw. Okay, so I kind of spend quite a bit of time together with you just to make sure you're very, very comfortable with this particular notation over here. It's a very brand new syntax to you, and also it requires quite a bit of thinking and understanding over here. Okay, again, let me recap very quickly, and then I'm going to end the current video, and then starting from the next video, I will try to trace a little bit further. Okay, basically what we have done so far. Okay, we try to show you that by using the new keyword, we can call a constructor from a particular class, right? And for a particular class, the constructor might be multiple versions over here, and we just have to see what exactly are the types of the input values that's being passed over here. In this case, it's going to be 3 and 4. If I simply say 3 and minus 4 over here, the 3 actually wouldn't match the character over here. So it cannot be this particular version, okay? It must be this particular version that's being called, right? Okay? So once we call that particular version over there, let me just undo that. Once we call that particular version, we're going to basically execute this block of code over here, and then we're going to assign some memory location with some starting address over here, and then with x and y, and then we're going to, in this case, 3 and minus 4. In the case of 3, it's going to replace every occurrence of the first input variables, new x, by 3, and then do the execution. And then eventually, what you should really realize is, this is how we draw, how we visualize the object creation. You have a new object over here of this particular type with x and y attribute, which correspond to the attributes over here, okay? And then you also have the object-specific values which we assign 3 and 4. 3 and minus 4 over here. So that's why we got 3 and minus 4 over here. And finally, the way you store the objects is indirect. So what you store is just the address of the objects, not the contents for the objects. So that's why we draw P1 indirectly points to where the object is stored in the memory. So that's how you draw the picture. So this is really important for you to get comfortable with. So we're going to draw this diagram over and over throughout the tutorial video and for the rest of the course. Make sure you're comfortable with it. Okay, I'll end the current video over here, and then from next video, we're going to go with more calls to the constructor, either the same version or different versions, and do some debugger testing.